Okay, rant time. Crash course physics. Why did I have to mention centrifugal force? Why? Oh, you can totally see how messy my bed is. But why? No! When I was learning centripetal acceleration and stuff, the maximum extent I had it mentioned to me was, oh, centrifugal force is false. It's non-existent. It's fake. Period. Don't even think about it. And then, I was kind of skeptical about it, but then we just learned this semester it's a fictitious force and, it only exists in non-inertial reference frames. Which, I don't know if Crash Course is going to talk about, but it feels like they shouldn't. Because, this is an introductory class, and, why did they even have to bring up fictitious force in the first place? Just to make it sound cool? That's not what physics is about. Just don't even mention it, you know? Like how, in introductory classes, it's like, oh yeah, the Coriolis force is non-existent. Let's move on. It does exist, but let's move on. Okay, Crash Course Physics. So, I did a ranty video last week, which, if you want, you click here to watch. And I feel like after that outrage and outpour, I don't know if it can happen again. So, if you want to go watch 5 minutes of Alice ranting last week, this was before I decided to separate out the travel with the rant. And last week I kind of included clips because I was frustrated. This week, they made minor mistakes, but overall, yeah, yeah, totally. But yeah, I still want to rant about physics though, because physics is so much funner than that. I learned physics so much differently from all the rest of the world. High school was when we actually started doing physics. And my tutor, because the summer before high school I was getting tutored, so my tutor was like, okay guys, we're going to talk about forces first before we get to velocity and acceleration and the general curriculum. And China starts with this velocities and accelerations as well, but I found that starting out with forces was way more intuitive. Because, a force in that direction obviously is not the same as a force in that direction. And then, that could lead to the concept of vectors, which, it depends on both direction and magnitude. Because the thing is, right, 5 meters per second this way and 5 meters per second this way is, at least for me at the time, they were both 5 meters per second. What's the difference? The direction shouldn't matter. But then, I understood forces, so my tutor was like, just think of it as a force. These are vectors. And I was like, okay, so they have to be different. And the uniform circular motion stuff, that just made so much more sense, because once you understood that velocities were vectors, you realized that to get from this velocity to this velocity, even if it was the same magnitude, you would have to have an acceleration pulling it inwards somehow. We learned forces first. It was really intuitive, and then we got into vectors and then velocities, and I was not able to understand the concept of acceleration for the longest time, and Crash Course Physics just breezed over it. Seriously, it's oh yeah, by the way, acceleration is the derivative of velocity. Have fun with that! You're not gonna understand it, I know. Physics, really, you really have to solve problems and think about it, which is kind of hard to do in a Crash Course type setting. But then again, there's so many awesome physics channels out there, so I know that it's possible. Also, my tutors, they've helped me understand this. And I know it's possible. It's definitely possible. But I definitely know it's hard. Physics is fun. I promise you guys that much. I'm not a crazy person. It's what Destin said, oh, you're a physicist, you must be smart. No. Physics comes intuitively to me. I like it when I can understand a thing. I was failing at every single liberal arts class I was taking. she like single-handedly raised my grade from failing to an A in like 2 months or something. Like I do not like memorization, which is kind of ironic seeing I have like 50 digits of pi down in the periodic table. But those are because, nerdiness stuff. I cannot memorize things. And for me, physics, it's not about the equations. It's about going into it, understanding it deep, and like being able to apply to different things, which is just something I love. Like, yeah, you have to start off memorizing the 5 equations of motion or something. But like now, I don't know what those equations are. Like, sure, I'll put it on my cheat sheet when I'm like going to test and stuff, but like I understand the fundamentals of where those equations come from, and I could derive them at will. So like, and also it's weird, like a lot of people talk physics like as if you're talking about math, whereas you don't need to know calculus to understand basic physics, like I said in my video like 2 weeks ago. But you seriously do not need math to understand some physics concepts. Let's go back to Crash Course. They introduced velocity as the derivative of displacement, and acceleration as the derivative of velocity. I mean, it's correct, but also v equals xt and a equals vt. Really, those are the 2 equations that you need to know. I learned about the concept of forces before I learned trigonometry. That was how basic my math was. Like the mass on the slope picture I use as my profile pics? That was when, like, we were learning how to balance forces and stuff, and like this was still in statics. And then so there were 3 forces on this mass, right? The gravity, the normal force, and friction. And then my teacher was offhandedly just mentioned, oh yeah, after you guys learn trig, you learn that you could separate out the gravity into like an x component and a y component, and then the x component balances friction and the y component balances the normal force. And I just found that really amazing. Like, you could separate variables that are seemingly connected. Like, you could just separate them all out and do regular stuff on it. And that just blew me away. And that was, I think, basically when I was like, I know I'm doing physics. It's simple, pure, beautiful, amazing. Okay, back to the separating out seemingly interconnected things. We were talking about Lagrangians, which are so beautiful. It's just like, okay, I'm gonna get mathy for a while, but like, you take the derivative, and then you take the derivative of one thing. You take the partial derivative of x, and then you take the partial derivative, the partial Lagrangian partial x, and you take the ddt of partial Lagrangian partial x dot. And that gives you the F equals ma equation, but it separates it out into like different components. It's so beautiful! It is so beautiful! Okay, that's a little side note that could be put away safely, stored within the history of unironic enthusiasm. But it's so beautiful. No, like, my physics friends would make fun of me as an engineering physics major. So like, they'd be like, psh, what's engineering? Who cares about rockets? Lagrangians are beautiful. And then I'd be like, yeah, totally agreed, but I love rockets. Lagrangians are really beautiful. And I love it. This semester we learned Fourier transform in and out. It's so cool. My knowledge of physics is on a whole new level right now, and I'm absolutely loving it. Other than that, I've been recording for 12 minutes, so I should probably cut here. Go watch my video ranting last week if you want. But yeah, other than that, bye. I'm in love with that thing. Okay, bye. I should get to editing this.